very much for coming or for watching remotely. But my name is Nick Jackson. I work at HashiCorp. For folks who've not heard of HashiCorp, it's a company we provide tooling which I suppose aids application development. Now that goes from deploying infrastructure to securing your infrastructure and your applications to actually running your applications and all of those kind of cycles of application security, application deployment, application development. My background is that I've got about 30 years working in the industry. For the last 7 years, I've been working at HashiCorp. Prior to that, I was working as an application developer. I ran an engineering team for a startup. And I've covered a few different things. What I want to talk about tonight is about application secrets. So predominantly the kind of the problem that you have that you need a secret, which could be a database credential, it could be an API key, it could be anything that's secret. And being able to kind of manage that process, being able to share those secrets, because a secret needs to be accessed by an individual, it needs to be accessed by an application, and a number of different things, and being able to do that in a secure way. So let's look at a little story on why that's important, I suppose. Is about 10 years ago, I used to work for Marks and Spencer in the digital innovation department, and we were doing something, and I can't remember what it was, but we were working on a project. And for that project, I needed to create some infrastructure. So I'm working, running up the mobile dev team, and we were creating a back-end service. So we needed to create some infrastructure. So we were embracing DevOps at M&S. So it was pretty much fine that, you know, if you can figure it out, we'll trust you to do what you need to do. It wasn't a critical system. So I needed to deploy something into AWS. And to deploy it into AWS, I needed some credentials. So I'm on Slack at work, and I'm sort of slacking our DevOps chap, and I'm like, hey, I need some AWS credentials. Generates me some AWS credentials. I take them out of Slack, where he pasted them, because I didn't want to lose them. And I pasted them into a little text document that I just had open on my desktop, where I was just keeping a scratch pad of notes. I thought, I'll put it there. And then what I'm going to do is I'll file that off safely later on. So I put it in there and I saved it. I did what I needed to do. And then I got a phone call, which was, did you just commit those credentials to GitHub? I was like, no, of course I didn't. I'm not that stupid. Well, it turns out I was that stupid. And it turns out I did commit those credentials, which were for our AWS account and actually production. The permissions that those credentials afforded anybody were quite numerous. You could have done a lot of damage.
So you can do your share now. So
yeah.
It'd be better if you did that. That's just.
So the benefit of what we actually had at Marks and Spencer was that we recognized that people would make mistakes, people mainly being me. And what we had was a process where we were actually monitoring GitHub. And we were monitoring GitHub for leaked credentials with the aim that we would catch it before somebody else did. And in that instance, that's what we did. I mean, there were a number of problems with that. One was we had credentials which didn't expire, had credentials which had completely the wrong level of permission for me as an individual. And I actually had the opportunity to make a mistake, which resulted in those credentials being leaked, which nobody really knew where they were used, which again is another problem. Thankfully, times, processes, knowledge, everything with hindsight has changed. And I want to talk to you about a process today where you can avoid all that kind of mess and hopefully a lot more. So we're going to look at secure and repeatable deployments. So why I'm kind of like, I call it secure and repeatable deployments, but what I find is that application, you want to give application teams the ability to deploy their own applications. You need to give them control for a number of different reasons. One, to allow them to move quickly. The other is that you want to give them the ability to move quickly, and you're resource constrained. So if you're working as in a DevOps team or a platform team or any form of team where you're supporting application delivery and deployment, you know, the kind of the number of you outweighs the number of the churn that's going on in applications these days. So by being able to kind of provide a devolved and secure capability to the application teams means that you don't have to kind of worry about the minutiae of the problem. You can concentrate more on policy configuration and enable those teams to work a little bit quicker. Now, to do all of that, sadly, we kind of need to look at three different tools, which I'm going to cover today. The three different tools are Terraform, and Terraform is a tool for deploying infrastructure. So why Terraform is important in an app InfoSec perspective is that Terraform allows you to have a repeatable capability for deploying your applications. It also gives you an audit trail of what has happened when. So that's really important from a security perspective, that I can control what's going out in the application. I can see what's changed. And in the instance that I need to roll anything back up, I've got all of that capability as well. So we can follow those sort of GitOps approaches. Now, Vault, what Vault's going to enable us to do is, firstly, it's going to enable us to store the secrets. So it's going to give us a way where we can put some secrets and we can control access to those secrets. So that's really kind of simple premise. It's a secret management system. And I'll get into more depth on that. And then the last part of the puzzle that I want to cover, which we'll kind of cover very briefly, is the kind of the human element. So as a human, how do I get access to a system? How do I get secrets for that system? We're going to wrap that up by looking at boundary, and all of these things are going to work together. Now, I just gone to sleep. So I'm Nick Jackson. I work as a developer advocate at HashiCorp. My colleague who is not here is Rob Barnes. He also works as a developer advocate at HashiCorp. He may come here, but ultimately you want to listen to me anyway, because I know a lot more than he does. And this is the system we're going to look at. So what I've done is I've tried to take a chunk of a system. So a kind of a slice of a sort of an application, a microservice it could be, or it could be a monolith. It doesn't matter. It's an application. So we have our microservice. The microservice has a data store. The microservice in this instance is public. It doesn't have to be. It could be an internal system, but we're saying it's a public system. And of course, the application needs credentials to authenticate against the database. Now, in this particular instance as well, in order to enable the application teams to be able to do some various debugging, maybe you've got a DBA who needs to do some maintenance, you've got to think about how they can actually gain access to Cloud SQL. So what we're going to do is, that's where we're going to bring access management and credential injection for humans into the picture with boundary. And again, I'll get into this in more depth, but ultimately the way that this is going to work is that Vault is going to provide all of the credentials that the application and the user needs. Boundary is going to enable the access. If you think of it kind of like a sort of a VPN-based solution. And Terraform is going to configure and deploy the whole thing. So step one, the application. So it's application access in terms of what the application needs. So what does an application typically need? Well, it needs secure network connectivity to a data store. And it needs credentials in order to kind of dig into the data store. So when we kind of think about those, I kind of think about those in terms of like there's three different approaches that you can do to enable this. Let's look at secure network connectivity. So the three different approaches. I think the bad approach is that when it comes to the network connectivity, all of your data stores, all of your databases, they're just on the public internet. Well, they're publicly accessible. Just YOLO them into prod and allow everybody to gain access to them. Now, we kind of know this, but it's the bad case. Now, good case, I think the good case around this is that we have a perimeter firewall or a VPC controlling access to the resources. So why I think this is it's a good case is it's fairly easy, it's fairly low low tech to be able to configure those secure boundaries. And we're going to kind of treat that as the good case. And then we've got the best case, which is that we want granular access control, which restricts the connectivity, not just between network kind of segments, but actually between applications. So looking at micro segmentation as opposed to a sort of a more macro segmentation. And what we actually want is the capability to have full access and audit logs, which are around that network traffic. And the reason that we want that is because in the instance of an instance where we have to do some form of some form of investigation or forensics to determine the cause, I think those access logs is all there. Now, I'm just going to rewind a couple of slides here because I would like to introduce you the guy who I said you shouldn't listen to, which is my good colleague here, Rob Barnes.
Sorry, I'm late, people.
So that's a very sort of high level overview of the kind of the problem around secure network connectivity. Rob, I don't know if you want to maybe add some color to specifically to this one. Why is public access to applications bad? Because
So I think the way you want to think about, you have to threat model everything, right? You have to try to understand the things that can happen to your application. That's going to affect your business. That's going to affect, your ability to serve your customers and meet your contractual commitments, right? Now, when we think about cyber attacks, not every time are we talking about people sort of breaking into your networks and stealing data and all that. The pillars of cybersecurity are confidentiality, right? So you're talking about anything that's sensitive, keeping that away from people that need not know these details. You're talking about integrity. So the data that you do have, how do you know that it has not been manipulated by malicious actors, right? And then you have availability, which is one pillar that is often overlooked by people that are not operating in the cybersecurity space, right? Just today, I read an article about a company that's one of the oldest and largest logistics companies in the UK has filed for administration, and the administrators are given the root cause of that as a cyber attack that they suffered, I think it was last year. So when you think about your applications and your databases being on the public internet, you are basically putting it right in the face of potential threat actors. Those threat actors sometimes will be external people that have a gripe. Sometimes it will be a teenager who wants to see if they can pull it off. Sometimes it will be an internal threat actor, someone who's disgruntled, not happy with their pay rise or not happy with their manager or something, and says, hey, I'm going to show them. And they can do this from the comfort of their own home because it's on the public internet. So, there are so many reasons why when you threat model your applications, generally speaking, having your most core and sensitive infrastructure components and application components on the public internet would be a bad idea, and you're asking for trouble.
So then we kind of went on and looked at, obviously we want to kind of avoid those situations. We want to look at putting in perimeter firewalls, which is probably the minimum of the security that you all would have in place to gain access to the resources. And obviously the sort of the granular control. Now, the granular control is not something we're going to look at today, but there's a lot of technology which has emerged around the sort of the micro segmentation, predominantly service mesh. No plugs mentioning anybody, but there's somebody in the room who's writing a book on service mesh patterns, which is going to be available for Christmas, maybe if you're looking for something for your children or friends and family. But ultimately, what I was really interested in around that is looking at how we can use tooling to actually enable things like granular access control, which was incredibly difficult to do in the past. We don't have time to talk about things like service mesh, but in our opinion, that is kind of like the premium option when it comes to things like network security. And then, of course, your database, obviously you need to be able to connect. The important thing is the authentication, and that's the goal here today.
So do we have our speaker notes or? Okay, I'm gonna try and do this from normal. So you've shown the application.
Yes.
Okay, so you have different components that need to connect to other components, right? And we talked about some of the stuff being on the public internet and why that's a bad idea. Also, when you have application components and infrastructure components that need to interact with each other, you want to put some form of attestation there to prove that someone or something that is trying to connect to this thing is indeed who or what they say they are, and they are authorized to perform whatever action they are trying to do. So essentially what we're talking about here is authentication and authorization, also known as auth-N and auth-Z, or Americans might say auth-Z. So there's a couple of ways that we can do this, right? We authenticate by providing a unique piece of information that says, hey, I am who I say I am, right? The way that we're very used to doing this is we have a username, and the unique piece of information that we have, that only we know, is a password, right? You think about when you go to the cash machine, you put your card inside there, you put in a PIN, a personal identification number. This is a form of attestation, right? So we have what we call the bad practice here, which is a static root credential. So a static root credential would be something that has the highest level of permissions. It's never rotated. It's often shared sometimes, right? Often shared. And that is what we would call a bad practice. We don't want a situation where if there's a leak, you're struggling to identify the source of where that leak came from. What's much better than that is if you have long-lived but narrowly scoped credentials, right? So similar to the last one in terms of the life cycle of it, but it can only do the things that it was designed to do. So if you have a database, for example, and an application needs that static long-lived credential to perform some functions, maybe it only needs access to a specific table. Maybe it only needs to perform certain actions to that table. Maybe it's read-only, for example. You would have something which is narrowly scoped to what that application component requires it to do. But it is long-lived, right? So if that does leak, then your blast radius is still quite big. And then what's an even better solution is having short-lived, narrowly scoped credentials. So the difference between this and the long-lived credentials is not only is the life cycle of this shorter, but you start to get into this cycle of ephemeral secrets, where secrets are automatically rotated on a short TTL basis. And that is kind of what some might call the holy grail of where we try to get to in our security posture. So I don't believe you've introduced Vault yet, have you?
I've just basically said what it is. I haven't covered how it works or any of the details because I knew you'd be here on time.
You have so much confidence in me. Right, so Vault, just to kind of recap, is it's a few different things depending on who you speak to, right? So to some people, it's a secrets management platform, which means it's a place where you can store long-lived secrets, and in all your applications that require them to connect to this centralized secrets management platform. If you need to rotate it, you rotate it in one place. It also is, in some cases, an identity broker, right? And what I mean by that is instead of storing static long-lived credentials, you can have it broker identity on behalf of your target platforms, right? I will give you an example. If we look at AWS, for example, if I need access to our corporate AWS account, rather than me having my own login that, is...
Can I just interrupt you? Go. So I'm going to give you a hypothetical scenario for the AWS thing that you're about to talk about.
Okay.
So just imagine that some idiot had AWS root credentials and committed them to GitHub. Nobody's going to do that, are they? Nobody.
You say that, but I've been that idiot before.
Oh, really? Oh, you see.
That's why you should listen to me.
Not the only idiot in the room.
No, that's the point of security. We have to protect ourselves even from ourselves. We make mistakes. So we need to put in structures and systems that prevent these things. So just to kind of go off of that example there, because of things like that, not only the external threat actors, but the incompetent robs.
And Nix.
Definitely Nix. Believe me, I've seen his code. If I want to access AWS, instead what I do is I say to Vault, hey, can you give me some AWS credentials? Vault acting as an identity broker, will go to AWS and create an account with the permissions that I require to do the thing that I need to do. And then it gives me those permissions, assuming that I am authorized to have these AWS credentials. Now, those credentials that it gives me have a time to live associated with them. So let's just say it's 5 minutes. After 5 minutes, if we don't renew the lease, and we'll talk a little bit about leases a bit later on, if we don't renew that lease, essentially renewing the credential, it will go back to AWS and say, hey, do you remember that credential that I asked you to create that I can give to Rob? Delete that, please. And it will go and delete that. So it gives you this narrowly scoped, short-lived credential. So your application components, if they're interacting with something like Vault, it can not have hard-coded secrets to access other application components. It can generate these things dynamically, right? So you can think of it as an identity broker in that sense. The other thing that Vault does, which we're not going to get into today, but I'll mention it just in case you're interested, it provides cryptography as a service. If you are a developer and you've ever been asked to implement cryptography into your application stack, you will know how difficult that is. You will know how error-prone it is, and it's just not a fun thing to do. Vault gives you the ability to encrypt your application data in transit and at rest, just using simple API interface. So you can give it a payload, tell it what key to encrypt it with. It will manage the whole life cycle of the cryptographic keys. You know, you can rotate these keys. It doesn't actually store your data for you. It just does the cryptographic actions. So in that sense, you know, it's also cryptography god almost, right? So, you know, some people will say secrets management platforms. Some people will call it an identity broker. I personally think of it as a standard library for security. So this is kind of the secrets engine side of things, right? So secrets engines is how we broker identity. It's how we store long-lived secrets. That's the kind of the main component within Vault that does that. But in order for me or my application to be able to get these things, I need to authenticate myself or authenticate the application, right? And we do that through a mechanism that we call methods, right? It's a pluggable construct, just like Secrets Engine is a pluggable construct. For example, Kubernetes, their version of identity is service accounts, right? So I can use my application's identity, i.e. my service account, to attest to who I am. I present this information to Vault. Vault goes back to Kubernetes and say, hey, is this valid? Is this actually what they're saying it is? And if Kubernetes can confirm that, then it will give me a Vault token, which has policies associated with it. And those policies then enable me to do the magic that we just discussed on this side, where we can interact with all these secrets, right? So when you think about implementing zero trust, and we're going to go a lot deeper than just buzzwords, right? Zero trust has been something to get good at SEO. But reality is, it's the foundations for building a solid house, right? If you are going to manage secrets and identity, you're going to want to do that centrally. And the reason why you want to do that centrally is because if you don't, and you have multiple systems all over the place with interdependencies, you are causing yourself operational nightmare. And these operational overheads will lead to mistakes, which lead to attacks, vulnerabilities, all sorts of things like that, right? So Vault's goal in this whole stack is to be your centralized secrets management or identity brokerage platform. And all of your applications, all of your humans connect to that in order to get their credentials. So we don't have any direct credentials for any of our target platforms, right? It's designed to operate at scale. You know, if you just have a few secrets, I'm sure you can use Vault for that. But if you have millions of secrets or millions of platforms, whatever it is, it can also accommodate that type of scale as well. It's all about how you interact with it. You have an API, you have an SDK, you have so many different ways to interact with it. And that allows it to be scalable even for the largest organizations, right? And as we've just kind of described, when we look at the secrets management side of things, it gives you the complete lifecycle management. So we've talked about the lifecycle management of a secret. We've talked about the lifecycle management of cryptographic keys. If we have a corporate policy, for example, that says that cryptographic keys need to be rotated every 30 days. Because everything is built from the API up, we can write automation that automatically does these things every 30 days. Now, the way that that will be stored in your database, I'm not going to get too deep into the cryptographic side of things, but just to kind of explain that, because I know the question will come up. what if you rotate the key? What does it do to the data that's in my database? Can I still access it? And the answer is yes. It stores multiple versions of the keys. You can configure even how many versions it will store. You can automatically delete older keys up to a certain version. The ball is in your court. The ciphertext that comes out of Vault for this will tell you what version of the cryptographic key was used to create this encryption. So it tells it what version you need to decrypt it as well. So like I said, I don't want to get too deep into that, but cryptography is a big part of secrets management as well. So I think we've kind of covered a lot of this already, just because I don't have my speaker notes. So I'm trying to do this off memory and I couldn't remember what slides are there. So I'm not going to go over this. We've discussed this at length. I think we've gone over this as well. We know what dynamic secrets are. Does everyone understand the concept of dynamic secrets as I've explained it? Or hands? Confidence? I don't see hands, so I'm going to go into it.
Well, we're going to demo it. So
Oh, I can demo it. Okay, cool. Don't listen to this guy, just watching. Dynamic secrets. So that's the concept of ephemeral secrets, short-lived secrets. It's, on demand. It's generated when you need it, and after a TTO expires, it's revoked. Now, everything involved when it comes to secrets is tied to a lease, right? So it creates this AWS credential and gives it to you and has a lease associated with it. Right? That lease tells you how long that credential will be valid for, right? Because the lease is the internal mechanism within Vault that's going to dictate whether you can continue using it, whether you can renew it, or whether it should revoke that credential. So if the lease is revoked, it's a one-to-one relationship with the secret is revoked as well. So everything about leases is about the life cycle. So you can renew leases and you can revoke them, right? It's all very simple to do. And Vault does a lot of that for you based on how you configured each individual secrets engine. So leases are enforceable. There's a couple of points there about break glass procedures, which makes it good. We've actually had a concept we built whereby you don't have access to production systems, but if your PagerDuty goes off and you are the on-call engineer that acknowledges that, it automatically gives you permissions for all of the infrastructure involved in that incident. The moment you've resolved it, it will revoke your permissions for that as well. So there's so many different things you can do, and leases make that possible. And this is next time. Right.
So what we're going to do is have a look at a demo of how we can configure dynamic secrets for the database, and then how we can inject those into our application so the application can consume them. So what the setup that I have is that I'm running Cloud SQL inside of Gkey. So, I mean, it could be an on-premise database, it could be Cloud SQL, it could be anything really. It doesn't really matter too much. Vault's got a number of different capabilities which enable it to work with a number of different data stores. So that's what I need to make this disappear off my screen.
I think you click the X next to the recording on.
Oh, we got it. Right, cool. So the way we're going to do this is we're going to look at doing this through configuration management. So
Can everyone see that?
No.
I can't see behind me. Look massive from where I'm sitting. Sorry.
There you go.
So we're going to do this using configuration management. Why are we going to do this with configuration management? Well, we're going to do it with configuration management because the first thing is we want things to be repeatable. So we want things to be repeatable and we want them to be consistent. Now, I have in my demo environment, I've got three different physical sort of environments. I've got a dev, a test, and I've got a production environment. Now, each of those environments have varying levels of security. So for dev, like there is no secrets or anything, free reign. For test, similar. Maybe you've got a slightly heightened level of security because maybe we're working on some test data, which is maybe not production, but it's certainly not something that we would want to leak. So we can, again, think about that. And then we've got production, which is a very, very special use case. Now, in my humble opinion, like nobody should have access to production until they need it. So I shouldn't be able to get access to production unless I specifically need it. And what Rob was kind of saying, in the event of an incident, But we're gonna, in all of those cases, what we're going to do is we're going to provide dynamic secrets to our application, and we're going to use Vault to do that. So can I figure out how to get rid of that? And I close that and that and that. So what I've got running here is my Vault server. And I've got everything configured in terms of Vault. So I have configured certain bits of Vault, such as the initial setup, things around the authentication, and I don't have too much time to kind of dig into too much depth of those, but please hit me up on that. I will cover what I can. I have my application, which is running on a Kubernetes cluster, and we'll see that running. And we've got our configuration management, and we are using Terraform to be able to do our configuration management. Now, whether you're using Terraform, whether you're using Ansible, whether you're using Chef, whether you're using Pulumi, doesn't matter. Like the thing is that you use a configuration management tool that gives you the ability to have an audit trail of change and to have, in ideal world, an approval process. Oh, zoom it up, sorry. How can I hide that sidebar? Well, the answer will be that I can't, probably. Never mind. We can look at that later. So let's dig into those things. So here I have, as I say, I've already configured my Cloud SQL database instance, and I have an application. So let me open up my application, which shouldn't be currently functioning. So what I like to do, because most people are developing Java for the enterprise. Well, Minecraft's written in Java, so therefore all enterprise microservices are really just Minecraft instances. So I built a microservice in Minecraft, and it is a functioning microservice. But we'll just kind of go through this and get to the bit that we're interested in, which is the actual inner working, which is around the door here. Oh gosh, why is my mouse over there?
Do you need a sat nav?
No, I want Mac to not do Mac things. Look. For reasons.
It's a universal control.
Oh, universal control. That's something that I wanted. Yeah. Thank you, Steve Apple or Tim Jobs or whatever his name is these days. So let's have a look at the microservice. So we're going to go into the microservice now. Our microservice is also secured. So the access to the microservice is secured, and we're actually using Vault for this principle as well. So in terms of to be able to authenticate or to leverage a secret inside of Vault, what you need is access. Now, I need a token inside of like the technical term of what Vault uses, and a token has permissions granted to it, and the permission is controlled via policy. So I can authenticate against Vault, and I'm authenticating to Vault here, actually using something that I have, which is my identity as a Minecraft thing. Now, once I have my identity, I can actually use that to be able to read secrets. And secrets allow me to open doors. So what's actually happening here behind the scenes is that Vault is using my token, the block is using my token, it's talking to Vault, and it is, well, we didn't want to do that. It is checking the presence of a secret. But this is the bit that we're most interested in. So this is our database here in our microservice. Now, the database actually has hard-coded credentials which have been configured. It's got the root and it's got the password. Now, that has been changed at some point. What we want to do is we want to replace this with dynamic credentials. So we're going to replace these with dynamic credentials. We're going to redeploy our Kubernetes application, which will then inject those secrets, and we'll be able to use them from our Minecraft service, which is going to be the next big thing. If anybody told you it was Rust, they are wrong. So let me just grab my notes. So the first thing that you need to do in Vault is you need to configure a database secrets mount. So again, we have authentication, we have policy, and we have secrets. Now, the database secrets engine allows you to dynamically generate those credentials for your data stores. And you do that by creating a database secrets mount. So it looks like this. Now, the path, so the path of the database secrets mount is where it will be mounted. So when in Vault, everything in Vault is basically an API path. So an API path is how you can provide access. So for example, I could grant Rob access to configure this database secrets mount by creating policy, which allows him access to the path. And we'll see that a little bit, but what I'm in essence is doing, I'm creating this database secrets mount and I am configuring a database connection. Now the database connection is going to enable Vault to be able to talk to the database, to be able to generate the credentials on my behalf. So I pass it the URL, which is going to be, it needs a username and password. So an initial username and password to connect. It obviously needs the location. This is basically a P-SQL connection string, and ultimately the database that we're going to use. Now, we're not going to look at that here, but actually what you can also do with Vault is you can actually basically give Vault that root access and throw away the root password that was initially created. So if you have a process where you're going through and you're configuring and set up your database as your initial state using configuration management, if you don't want that initial root password to leak anywhere, then what you do is you configure your database mount, you tell Vault to rotate the root password, then nobody has the root password but Vault, not your configuration management system, not your DBAs, nobody. So then to get access to the database, we're going to use these roles.
Can I just interject there? So because of that, if you get yourself into a situation where you give that root credential, and that's the only root credential you've got, and you get into an extreme break glass situation, it's advised that you should create a separate root credential specifically for Vault, right? If you're going to have any other root credentials, that you shouldn't give that to Vault, because once Vault rotates that, no one's going to know it but Vault forever. Exactly. Yeah.
So we're going to create a role. So a role is going to kind of define the access privileges that a thing, be it an application or a human, will have on the data store. So I'm defining this role here, which is going to be sort of simulating a database reader. Because what we want to do is we want to be able to provide that fine-grained access. So if you don't need to write to the database, you shouldn't have the permissions to write to the database. And likewise, if you don't need to read from the database, you shouldn't have permission to read from the database. We want to be able to only allocate the specific permission that's needed. And we can do that through a role. So we're going to give it a name, and I'm calling it reader. And we're going to give it we're going to pass it the link to the database. And then what we do is we specify these creation statements. So in order to create the user, what Vault is going to do is it's going to connect to the database using those root credentials, and it's going to execute that SQL. So you can literally specify any SQL that you like, well, in the instance of a database, obviously. So here, what I'm doing is I'm creating a role with login password. So this is just a P-SQL command for creating a user, with a valid until expiration. Now, the expiration is going to be automatically injected by Vault based on the TTL that we configure. The password is obviously going to be automatically generated, and so is the name. So these are just template placeholders. And then once we've got the role, what we can actually do is we can execute another SQL, which is going to configure the permissions that role has. So in this instance, it's basically just going to configure select permissions to read a role on the counter table in the counter database, because I'm going to imagine it's a chat like that. So with exactly the same principle, what we can actually do is we can create multiples of these roles. And this is exactly what you would do. You would create multiple roles to define the various privileges that things need over your data stores or your applications or your AWS accounts or anything that can be managed with Vault. So this time I'm creating a more permissive role, which is actually giving read and write access. And I can actually do a slightly different role as well, which is I can do an importer role. Now, the importer role is ever so slightly different. Now, what the importer role allows me to do is basically run database migration scripts. So that is its sole purpose. Now, this process is executed as a Kubernetes job, which means that the secrets which are deployed to that Kubernetes job could be long-lived. So if you can gain access to the Kubernetes server and you can dig those secrets out of there, then potentially you get very permissive access over the database. So how do we counter that? Well, we know that the import job takes about 5 minutes. In fact, it doesn't take that long. So what we can do is we can specifically tailor the life that those credentials will live. And what I'm doing here is I'm actually setting the life of those credentials to 100 seconds. So once these credentials have been created and they've been given to the Kubernetes job is going to execute. It's going to finish and it's going to disappear. What Vault is going to do is Vault is going to keep track of that lease. It's going to say, well, they were issued with 100 seconds. So after 100 seconds is expired, it goes back to the database and it executes a revocation statement, which actually disables the user. So the fact that those credentials, very permissive credentials, exist inside of a secret on your Kubernetes cluster, they're only there for 100, or they're only valid for 100 seconds, which is a really nice way of kind of giving a nice balance of flexibility. So let's just apply this. And then what we can do is we can see that working in action. The way that I've got this set up is I'm doing the whole kind of GitOps approach. So my Terraform code here and my application code, which exists in a repository, gets pushed to GitHub. We go through the whole build process, and then the automation will actually execute the changes. And we will talk about some of the important points of that when I'm done. But I'm going to cut a corner. So rather than wait for the whole build, I'm going to manually just execute the changes to the configuration. And I'm doing that with the Terraform apply command. So all of this code here that I've written, Terraform understands the differences between what currently exists, what will exist, and it can go and it can configure my vault, deploy my applications, and do anything that we need to do. The benefit is obviously because I'm doing that Git flow, there's a full audit trail. There's a full audit trail, and you've got the ability to do the GitOps approach of being able to go from dev to test and then into prod. So for me as a developer, just give me access. If I'm breaking dev, my problem. There's no secrets there. There's low risk. Allow me to kind of experiment. When we get to test, pretty much the same thing. Maybe you want to take a little bit of extra security. When it comes to prod, you absolutely should not be allowing me to push straight into prod. There needs to be an auditable action where somebody has said, what Nick has done is okay. And that is because we have production data, we have secrets, we've got things that we need to think about, and we'll explain why it's actually important. Okay, so I'm going to hit yes there. We are going to go and see this actually in action. So we will see if I go over, oh, here we go, over to here. So we can see that even though I ran that command locally, Terraform in Terraform Cloud is actually doing the work for me. Now, the benefit of Terraform doing the work for me, which it's actually now done, is I don't actually have any of the secrets to be able to control my infrastructure. So I can't even commit these credentials to GitHub if I wanted to. And trust me, I want to do it.
Must be wrong.
Yeah. So then let's look at Vault. So now if I go into Vault, and what I've done is I've cut my Vault up into different sections, because again, as an application developer, I've got permission over certain sections. I can do what I want to dev. I can do mostly what I want to test. I absolutely cannot touch production. But we can see that we've now configured this secrets engine. We can see that we've got these roles which have been configured. So we've got our importer, our reader, and our writer. We've got the connection there. And then what I can actually do, let me just hit get credentials. What's actually we've got there is a username and password. Now you can feel free to copy those because they're going to get wiped out in 100 seconds. So good luck finding access to my database and using those credentials before they're revoked.
Actually, it's 1 hour.
Oh, it's 1 hour. Okay. Well, still good luck because
Hurry up.
yeah. So the thing around that is that the way that what Vault has done is it has talked to my database in GCP. It's executed the SQL that I've configured, and it's injected those credentials. So let's go back to our application. Now, in terms of our application, what we're going to do is we're going to look at a sort of a typical example of a Kubernetes deployment. So again, I'm using Terraform to kind of define that Kubernetes deployment, but the principle or the process of what I'm going to do is exactly the same regardless of what you use to deploy your Kubernetes applications. And the key thing that what I want to do is I want to take that secret from Vault and I want to provide it in a way that the application developers can consume it in a way that they understand, least friction. And the least friction approach is that we're going to take the Vault secret, we're going to inject it into a Kubernetes secret, and we're going to keep the thing up to date. So let's go through and let's do that. So the first thing that I need to do is, and I'm doing this my Terraform, is I need to create my secret. Now, what I can do with Terraform is I can actually read a secret from Vault. Now, this data element will allow me to read a secret from Vault. This resource will allow me to create a Kubernetes secret with the product of that data element. So this is one approach of how you can actually get those credentials into Kubernetes secrets, which can then be consumed by the application. The better approach, in my mind, which adds a little bit of complexity, is to use something like the Vault operator. And the Vault operator will automatically manage the syncing, but the principle is get a secret from Vault, put it into a Kubernetes secret.
Can I just add a bit more color to this? So the reason why that's a better approach than this is what will happen is this data is going to read the secret from Vault and it stores that in sort of like local memory, and then it will inject it into this resource here. But the problem is when that secret has expired, because it does have a lease associated with it, 1 hour, this doesn't know to, look for a new secret or anything like that. So this is kind of still external to Kubernetes. Whereas if you look at the approach that Nick is about to explain, this is very Kubernetes centric. So you can have the goodness of the lifecycle of the secret being managed for you and injected at the right times into the application.
So that, there are a number of different approaches to getting those secrets into the kube cluster, which cover varying levels of complexity. In my personal opinion, at the moment, the best approach is to use the config operator for Kubernetes. Like the benefit of this approach is, you could use this approach for anything. If you were creating a virtual machine, this still applies, right? It still works. The thing you've got to think about is the life cycle of that secret. When does that secret need renewed? So when you're dealing with least secrets, that's a really important thing to consider. So we're creating those secrets there, and then what I'm going to do is I'm going to just create a local, and what I'm going to do with this local is I'm just defining the environment variables which will be added to Kubernetes. And the environment variables, I'm just going to add the host, the username, the password, and the database, and they're going to be injected from that secret. So of course, to be able to get them into the Kubernetes cluster itself, what I need to do is to use the environment block. So with Terraform, it looks slightly different than if you are looking at, say, the Kubernetes manifest here, where we've got well, we don't actually have an environment variable. Oh, we do there. We've got those environment variables. The way that we're doing it is we're we can actually build up this configuration dynamically using Terraform. So there's another reason why I like to use Terraform over flat YAML files, or even processing with kubectl, Customize or Helm or various other approaches. But we have this we've got this dynamic. So we're injecting those as environment variables. Now, something to think about. Environment variables in Kubernetes are incredibly easy to consume, very easy to use, but they never get updated. If the underlying secret changes, the Kubernetes environment variable will never get updated. If you want to have something which is continually updated without having to restart your pod, you need to use a secret which is mounted to a volume mount, or you need to use a config mount. Secrets in volume mounts are generally the best approach. So again, there's something to think about there, because we're dealing with time-limited secrets. So now your application development team needs to understand that that database username and password that they've been given could have a shorter life than the deployment of their application. So at some point, they need to handle the reloading of that or the refetching of that. So we've got all of that set up there. Let me do a Terraform apply. I'm going to do that. It's now going to redeploy my application. As I say, just pretend that I've created a commit and I've pushed that through my Git flow. But this is going to tell me that what's changed. So again, like from a security stance, why I like using Terraform is that Terraform tells me very, very, very clearly what has changed. And that's really important. So not only can I can see a sort of an actionable thing here, which is this stuff has changed. Do you want to allow that change? Right? But also it's auditable. I can actually see that change over history. So for the instance that we need that forensic evaluation of what went wrong in the instance of a breach, then we have that too. So I'm going to hit yes there. I'm going to deploy that. We're going to create the secret inside of Kubernetes. We're going to update our deployment. If we go over here, we do kubectl pods. You can see that my dev server is terminating. New one will start in just a moment. And then that's gonna start up. Now I've got my application, which can now leverage dynamic secrets. So we'll come back to that because it takes about a minute for that to deploy and to instantiate. And what we'll do is we will dig into a couple of slides where we can talk to you about the things that you need to think about when you're dealing with infrastructure access. When I say we.
So if you've seen what Nick has done is he's used Terraform to configure our application components. But in order for Terraform to do that, it generally needs credentials of its own, right? So we refer to those credentials as secret 0. It's the first secret that unlocks access to all the other secrets that your environments are going to need to perform their functions. Right? So there are a couple of things that we need to sort of bear in mind when we're dealing with these types of systems and how we manage the secrets around them. So the main challenges are, not only does it need these secrets in order to configure the target platforms, but the secrets are generally going to be a lot more permissive than the average secret you'd give to a user, right? They need quite high-level permissions to be able to do different things. We'll go back to the AWS example, right? If I give it something narrowly scoped to, say, EC2 instances, and then I write some Terraform to do something with EKS, well, then Terraform will fail because it just does not have the permissions. You'll get the permission denied. So generally speaking, you need to give these platforms, well, you need to give things like Vault and Terraform, in this case, quite highly permissive credentials there, right? So you need to figure out a way to inject that secret 0 into this in a manner that is secure. Now, me as an operator who's configuring these systems here probably should never have the secret itself when I'm configuring the system. Right? Which is why when we look at Vault and we look at the idea behind identity and how you can use auth methods to attest to your identity, it's actually pretty slick, because essentially what you're doing is you're using the target platform's identity construct to authenticate yourself in order to get access to secret zero. And Terraform operates in a similar way. You can give dynamic credentials to Terraform so that it will automatically rotate, and every Terraform run where it's required, it will have dynamically created credentials. But we need to think about these things, right? We need to think about how we're getting secret zero into there. We need to be extra careful because they're a lot more permissive than the usual secrets. Have I just gone over everything?
Sort of. I think the key thing is that to remember is that if I've got the ability to change the Terraform, even though I don't directly have the credential or for the underlying cloud platform or whatever it is, I can change the Terraform. I've indirectly got those credentials, which is why credentials, which are given to infrastructure management tooling, has to be as narrowly scoped, and that the access to the infrastructure management has to be the same level that you would expect the person to have had they no access to infrastructure management, or if they'd had just the credentials that you give them. I think that's a sort of an important thing that is forgotten, but there's a lot of stuff around the sort of the recent attacks with supply chain management, and what the attackers have found is that the systems have been a little bit too permissive. So they've realized that by directly attacking a system, that's one way of trying to get access. But what they've really found is that people have been doing things like putting root credentials in their CI/CD platforms. They've been putting permissive credentials inside of their infrastructure management. So if you can infiltrate that area, then actually what you can do is you can provide yourself access to the rest of the system. So it's incredibly important to bear that fact in mind.
It is very tricky to do that, but nonetheless, like I say, it will be more permissive, but you have to be careful how you handle that. And then is this me or you?
Well, we can kind of like dive straight over this. So what we're going to kind of look at the last part of the puzzle, which is we've configured the credentials for the system, but as an individual, I need access to the data store, and I need credentials to be able to access the data store. How am I going to go about those? So we're running a bit on time, so we'll kind of make this brief, I think. But we want to kind of show you how those dynamic credentials can actually tie back into the individual, into the user, in the same way as the application.
So there's two kind of areas we need to think about here, right? So firstly, how do I physically get from my laptop to the database in this example here? How do I make that network connection? And then the second thing is credentials itself, right? So when we think about bad practice, as we discussed before, you would have these things on the public internet, right? That would be a bad practice. The other bad practice is once I get to the database, the credential I use to authenticate my identity is a shared credential. So that's not really attestation, is it?
So what you're saying is that if I had the root credentials on a post-it note stuck to the bottom of my monitor, that's it.
Yes.
But it's easy to get them though, because I just copied them off your monitor.
Don't listen to me, that's what he says. But essentially, you have to think about credentials as identity, right? So if you share credentials amongst different things or different people, you're basically sharing an identity. And that makes things a lot trickier to manage, right? So this will be a bad practice. A better practice than that would be to have some sort of VPN or VPC controlled access, right? So you would be able to create a secure tunnel from your laptop into your private networks, at which point you can then access the things that you need to access, right? How you would do that is with a set of long-lived personal credentials. So when I join the team, I'm given a username and a password or whatever, maybe a TLS certificate or something like that. And that is how I attest to my identity, and that gives me access into the network. Now that's better than having things on the public internet, but there are some challenges around this, right? And some of those challenges are, if you've used VPNs, the UX is terrible. Like as an end user, it's a horrible thing to do, right? You also have very complicated scenarios sometimes where you VPN into a network only to have to VPN from that network to the actual network you want to get to, right? So you have this multi-hop scenario. Again, this is a terrible UX, and spare a thought for the network engineers that have to manage this infrastructure. It is painful and very complicated to do. The other issue is once I'm in the network, well, I'm in the network, right? I can do whatever I want. I can laterally move to anything, whether I'm supposed to be there or I'm, right? And if you look at a lot of the attacks that happen, it happens via lateral movement. They never actually get directly to the thing that they're trying to get to. They normally target a weaker area and laterally move to their golden prize. And then we have the issue of long-lived personal credentials. If I accidentally leak that credential there, it's a problem, especially if I don't know I leaked it. What's the best way to go is instead of using things like VPN, we use systems that give us point-to-point restricted access on an individual basis.